All right, today we're going to dive into the history of a piece of tech that, for more than a decade, has been fundamentally reshaping the world of databases. And look, this isn't just going to be some dry technical overview. This is really a story about a relentless hunt for speed, a journey that shows you how engineered systems evolve, where every single step was about finding a barrier and just smashing right through it. And this timeline, well, it lays out the whole story for us. We're starting way back in 2008 with version 1 running on HP servers, and we're going to follow this path all the way to a vision for 2025, an AI-driven universal platform. But the one thing that connects every single one of these releases is actually pretty simple, but it's incredibly powerful. Find the bottleneck, and then absolutely shatter it. So where did this whole thing even start? Well, it started with the very first, and maybe the most frustrating bottleneck in all of computing, literally just getting data off of a spinning mechanical disk drive, you know? It was slow, it was physical, and it was the first huge challenge that Exadata was built to conquer. So what was this original sin of computing performance? For decades, it was this massive gap between how fast a processor could think and how fast storage could deliver the goods. I mean, you could have the fastest CPU in the world, but it would spend most of its time just sitting there, tapping its fingers, waiting for a little mechanical arm to find data on a spinning platter. That slow I/O, that was the problem that had to be solved. And here we go, the first shot fired in that war. Back in 2008, version 1 shows up, and it introduces something called Smart Scan. Now, this was a radical idea at the time. Instead of dragging massive amounts of data from the storage all the way over to the database server just to filter through it, the question was, why not push the processing down to the storage itself? Let the storage do the work of finding only the data you need. And that one idea, that single concept, directly attacked and broke that classic I/O bottleneck. But of course, once you fix the biggest problem, what happens? Well, the next biggest problem gets a promotion, right? With that disk I/O bottleneck weakened, suddenly new limits in memory and processing speed became the next big targets. And this kicked off a whole new phase, an era of just intense hardware acceleration. And the pace of development here was just incredible. V2 in 2009, that's the moment Oracle takes full control of the entire hardware stack. Then X2 comes along with powerful compression. X3 introduces blazing fast in-memory flash. And then X4 unleashes massive parallelism, which is basically tackling problems with huge numbers of processors all at once. Every step up this ladder wasn't just some minor update. It was a targeted strike against whatever the next slowest part of the system was. So, what was the cumulative effect of all this innovation? A real order-of-magnitude leap in performance. We are talking a 10-fold increase in speed. By engineering the hardware and the software to work perfectly together, this era delivered this raw power surge that it was impossible to get with a bunch of off-the-shelf parts. So after conquering raw hardware speed, the next big challenge wasn't internal at all. It was completely external. The entire tech industry was shifting, and shifting fast, toward the cloud. And that meant Exadata had to evolve, right? It had to go from being this powerful but kind of rigid on-premises appliance into something way more flexible, something ready for a new, hybrid world. And this really captures that fundamental change in thinking. I mean, the old on-prem world was all about these static siloed systems. You had fixed hardware, you bought enough for your absolute peak workload, and the rest of the time, a lot of it just sat there idle. The cloud demanded the exact opposite: elasticity, so you can scale resources up and down, and convergence, so to all work seamlessly, whether it's in your data center or in the cloud. And you can see the strategy, the path they took, laid out so clearly in these releases. X5 took that first big step with elastic configurations, which made the hardware a lot more flexible. X6, that was the pivotal moment. That was true cloud convergence, making Exadata work the same in the cloud as it did on-prem. And by X7, the platform was already looking to the future, baking in security and machine learning to set the stage for everything that came next. You know, this whole journey is summarized perfectly in this one quote from the source material. It's the entire story in a single sentence. The arc is clear, from breaking the disk bottleneck to building a self-driving database. The mission started by fixing a hardware problem, that slow disk, and now it was heading towards solving a much more complex problem, making the database literally drive itself. And that brings us to the climax of our story. The focus shifts, and it shifts dramatically. It's not just about making the hardware faster anymore, it's about making the entire system smarter. We are now at the dawn of the autonomous database, where the machine itself really starts to take the wheel. Because, as it turns out, after you've optimized every last piece of silicon, the final bottleneck
It wasn't a component you could just go out and buy. It was the complexity of managing the system itself. It was a potential for human error, all the time spent tuning and patching and securing. The ultimate performance gain was going to come from automating all of that away.
And so this final chapter unfolds right here. The X8 in 2019 officially kicks off this Automous era. From there, X9 expands all these capabilities into hybrid environments. X10 integrates cloud-native AI, that's intelligence designed specifically for the cloud, right into the platform's core. And the upcoming X11, well, that aims to fulfill the vision of a truly universal platform, one that can handle any database workload, anywhere.
So as we trace this incredible arc, from a simple hardware problem all the way to a self-driving, AI-powered system, it really leaves us with a fascinating question to chew on. As these complex systems learn to manage themselves, to tune themselves, and to secure themselves, where does that free us up to focus our own creativity and our own ingenuity next? What is the next great bottleneck for us to solve?